That's right. It's time for more than you ever thought you might conceivably want to know about scales in this lifetime and beyond. By me, your host, David M. Bashwiner, Associate Professor of Music Theory at the University of New Mexico. So, what's a scale, and why should I care? I suppose I get paid to be here, so why should you care? Let's phrase it that way. In an earlier presentation, I asked you to imagine you lived in a culture in which there were no musical instruments and no scales, but there was singing. Your job was to figure out how to measure the intervals between the sung notes. So we kind of did this. We'll do this a little bit more today, but let's say we have done this for a bunch of melodies and that now we want to figure out which scales are used to construct those melodies. One question is, does each melody use all the possible notes, or does it use only a subset of them? Another question is there a resting tone or tonic to each melody or scale? And then what is the pattern of intervals between the notes of the scale? And I think I will just point out that this question about, let's say we have done this for a bunch of melodies, and now we want to figure out which scales are used. This is something that actually was sort of happening in music history. The Catholic Church in Europe had melodies, and we'll be looking at those very melodies in a sense, but they didn't really have all that much theory about what key each melody was in. They didn't have a notion of keys. They did have a notion of modes from the ancient Greeks, but they didn't really actually know how to read the ancient Greek treatises. They didn't know necessarily what they meant musically. And then when composers wrote those melodies, they didn't necessarily write them in a certain key or mode. So this really does happen where they've got melodies that they've written, and then for several hundred years, as the theory of modes and scales develops, theorists start trying to put melodies that already exist into one or the other mode or scale, but it always doesn't usually fit perfectly. So this is a real life question to ask. So this is a review. We saw this slide. Here is some audio from Populus Sion. Okay. So what we did in there was we used the software Pratt to just find the pitch. And then we looked for pretty flat areas and put flat purple lines where there are flat areas. And that suggests those are the pitches. And there's some fluctuation within the pitches, but we are sort of quantizing those pitch areas to be different notes. But then the next question is, how do we measure the distance, the interval sizes between those purple flat lines? How much higher or lower is each pitch relative to the previous? So here is the answer, in a sense. So you could create an instrument with tones in simple mathematical ratios to one another, and then figure out which pitches you're singing based on the pitch collection you have. That's sort of based on our presentation from last time about Pythagoras. And since consonances sound nice, and you're probably singing intervals that sound nice, there's a good chance your math will give you the sounds you want. It's more complex than this, however, because ultimately you want to derive all the possible notes that you might use, and the math is infinite. But in truth, you don't have to use math at all. You can use your ears, since sounds in simple mathematical proportion sound consonant. And this is actually a super fascinating fact of musical nature, musical biology, basically, that we hear as consonants, sounding nice and pleasant together, we hear as consonants this quality of mathematical simplicity and relatedness. So if you remember the story about Pythagoras walking through the forest, he's walking and he hears the sounds of the consonances, and that's all surprising to him. And so he goes and he then measures, the weight and the density and so on of the hammers. He goes and he does a similar thing with string lengths and string tensions. And he finds that it's simple mathematical relationships, 1 to 1, that's an obvious one, but 2 to 1, 3 to 2, 4 to 3, 5 to 4, etc. These very simple fractions, basically, govern what makes sounds sound nice together. So it really is a very interesting fact that even before you go and try to measure the weights of the hammers, say, or the lengths of the strings, you can hear whether they sound pleasant together, and that you're basically hearing math. Okay, so let's say we want to make a scale using this basic idea. There's lots of ways to do this, but I'm going to use this one way that is the simplest, I think, and the most instructive. So we're going to start with a single string or a single note, doesn't matter, and we're going to find the perfect fifth above it and below it. So we're going to say our starting pitch is a C. We're going to call this the tonic. Then we're going to find a G above the C. So a perfect fifth above C would be G. And, if we don't know that, we don't have names for these notes yet, we're just using a ratio of 3 to 2. That means, if we had the length of a pipe, say, or the number of vibrations per second, we could multiply it by 3 over 2, and we would get a G. And then you get the opposite if you divide the string in half, but let's say we have a C string that's the whole, the length of 1, and we do 2/3 length of that string, and then we'll get a higher note, right? Because we're shortening the string, and that will be a G. We could similarly just touch it lightly at that place, and we would get the third harmonic, which is going to be a G an octave above. So in any event, we can derive a G from a C. That's the point. So we're going to call the G the dominant. And then we're going to do the reciprocal, or the opposite, using a 2:3 ratio instead of 3 to 2, or the equivalent, which is like we want the sound of a C to be the third harmonic of a string, or the sound produced when you divide the string in 2/3. So we're thinking of, in the same way that the tonic string generates the dominant, we can think of the subdominant string as generating the tonic, or you generate the subdominant from the tonic by the opposite way. I know that's a little bit complex, but you don't have to understand what that means for this class, but you might understand it a little bit better on the next slides, and if not, perfectly okay. It's a complex concept. So, in any event, we now have 3 strings. A C, if we went down a fifth, we would get an F. We could go up a fourth, but I'm thinking down a fifth to get an F, and we go up a fifth from C to get a G. And we're calling these tonic and subdominant and dominant. Now, I'll show you this in the next screen, but pretend these are each, we have an instrument now that has 3 strings on it, a C, an F, and a G. And above each of these, we're going to generate a harmonic series. We're going to take the 4th, the 5th, and the 6th partials. So I'll show you that on the next screen. And what that's going to do is produce a major chord on each of these basic generator notes, these strings. So from C, we're going to get C, E, G. From F, we're going to get F, A, C. And from G, we're going to get G, B, D. And what's super cool is that when you compact this all into a single octave, that set of pitches is just what we call the major scale. So let's take a look in more depth. Okay, so here we have a harmonic series. You're going to see a cellist playing just the C string, the low C string. You can see here that what's the note, the low C. Then the cellist is going to divide the string in half, just a light touch with the finger, and we'll produce the sound. Then we'll divide the string in 3 parts, touching it at either the 1/3 point or the 2/3 point, and you'll hear this note come out. And then he divides it into 4 parts, and you hear this note come out. Basically, all these notes are generated as overtones of the whole string. Overtones, harmonics, partials, all the same thing. Let's give a listen. Now, I just want to point out 2 things about this. One of them, if you look at harmonics 4, 5, and 6, partials 4, 5, and 6, that's actually the same thing, but you get C, E, G. So you get, from a C string, you get a C major chord. Okay, and then one other thing to know about this is that B flat, it's out of tune, it's flat compared to the B flat that we have on the piano. So in a sense, this 7th partial is the flat 7th above C. But in another sense, it's an out-of-tune note that we don't use. There's sort of debate about that. So let me show you this. I know it looks like there's a lot of lines here, but I think it'll be less confusing. So what you're going to do, what I've done is I've taken the C harmonic series. I did shift it up an octave here, but it's on C, C, G, C, E, G. Harmonics 4, 5, and 6. I'm only going up to the 6th one, and I'm going to show you that if you take C, E, G, then you do the same thing and generate a series on G, and you get G, B, D. And you do another series on F, and you generate F, A, C. You take all those notes together, you arrange them like this, your subdominant notes, your tonic notes, and your dominant notes, and then you put them actually in order. You generate the major scale. So check that out. Okay, so those are harmonic series up to the sixth partial generated on the tonic, dominant, subdominant. Now I'm going to order them from subdominant to tonic to dominant, just so they're all going upward. So I'm just selecting harmonics 4, 5, and 6 from each one. Now I'm reordering them to put them all within an octave. So if you're ever asking where does the major scale come from, at least this is one of the theories as to where it comes from. So all the notes in the major scale come from either the tonic, the dominant, or the subdominant chords. And a lot of them have both, right? This C comes from both the C chord and the F chord. This G comes from both the C chord and the G chord. And this C, again, from both C chord and F chord. So every single note in the major scale belongs to one of the three main chords. And why do you have the three main chords? Well, from the tonic, from a string, you could generate just the fifth harmonic, which is there. And then, the third harmonic. And then that would be the dominant. So the dominant is generated from the tonic, you could say. And then you could ask the reciprocal question, what generates the tonic? And the answer is the subdominant generates the tonic. And that you have an F here, which generates a C. And if you follow this series up high enough, it'll generate a C major chord too. I just gave you an acoustics or physics explanation for where a scale might come from. Let's go back and think about Pseudo-odo. So this guy was living in, I think, 900 AD or CE for Common Era. What he was doing in this treatise that I didn't really highlight the first time around, I was just having you read the notation, but what he was doing was showing you intervals. So with this clef, that's a C, that's an F. So here he's got E, F, starting with E, F. Here he's got F, E. Then the next pair, this is an F, so that's a D. Here he's got C, D, and here he's got D, C. So he's showing you how you can begin a melody going up a semitone and down a semitone. Here he's showing you how you can begin a melody by going up a whole step or whole tone, down a whole tone or whole step. Here he's going D, F, and then here he's going to be going F, D. So he's showing you could start a melody by going up a minor third or down a minor third. Here he's showing you that you could start a melody by going up a major third from F to A, or here down a major third, A to F. Here he's going up a fourth from, that looks like an A to a D, and then this melody starts by going D down to A. So you could start with a fourth, either going up or down. And then this last one starts by going up a fifth from D to A, or down a fifth from G down to C. So that was the point of that treatise. And he was using all these melodies that people already knew. We obviously don't have these remembered. But in the same way that we use Here Comes the Bride for memorizing perfect fourths, he's giving you that idea with these melodies. So, but a question to ask is, he's thinking in intervals, but like, whoever wrote these melodies, were they thinking in scales? I mean, I told you a couple minutes ago that like people weren't really thinking of scales necessarily. It was hard for them to figure out what scales their melodies were in after the fact. So let's do a little experiment then. Because let me just say that they could have been, whoever was writing these melodies, they might have been using scales without knowing that they were doing it. In the same way that when we speak, we use grammar without being fully aware that we're doing so. Okay, so we take a bunch of melodies that are, here they are notated. And we identify the pitches for each. We could do this the way we did it with Populusion by using that computer program. But here we're just taking a shortcut and looking at them written on paper. So in that first one, I just collected all the notes. I didn't repeat them, but E, F, D, G, A, B. Okay, so what I'm going to do is give you a summary of basically all the notes in here. F, E, D, E, F, A, G, A, G. Those are actually all the notes. Here we go. We have C, D, D, E, D. So C, D, E, D. D, C, E, F, G, etc., a bunch of stuff. This is just repeats, but then there's also an A in there. So I'm giving you sort of like all the original notes. D, C, E, F, G, A. Here we have D, F, D, C, F, A. F, G, F, A. F, D, F, E, C, F, G, A, G, B flat, A. So I'm skipping some of the repeats, but those are all the notes that are in that melody. F, A, C, D, C. There we go. A, F, A, C, B, A. A, D, C, F, D, F, E, D. Okay, etc. And then there's some more stuff, but we're just ignoring it. Oh, I guess if we go all the way down here to C, G, C, D, A, B flat, and then some more notes, but we're ignoring those. Back up here. I'm just showing you the beginnings of these D, A, C, D, etc. And then for this one, D, A, B flat, A, G, E, F, G, etc. Okay, I figured this would be enough to just give us a sense of what's going on in these melodies. There's only two possible key signatures for these melodies. Either they've got a flat in them or not. And those are the original two key signatures, either no sharps or flats or one flat. So let's take all these notes together and see if you can just put them into a single scale. I kind of spoiled it by saying there's two different key signatures. So you'll see that that's one of the main problems. If we add all these notes, what do I mean by these numbers? I know I've told you this before, but middle C is always C4. So this C thing, the C clef, always means C4. So if that's C, B, A, G, F, E. So this is E3, E4, right? This is in the middle of the bass clef staff. That's how you do that. So the lowest note we have in this whole collection is, where's the A? A down there. And that's A2. That's D3, C3. Toward the lower end of the bass clef staff. F, which is the F clef, F, F3. Okay, so from the bottom lowest note to the highest note, we have A, 2, C3, D, E, F, G, A. There's a B flat and a B natural, if we include all these melodies together, C and D. So is that a scale? It doesn't really work too well as a scale. I figure like maybe I should sing this, hold on. So we have A, C, D, E, F, G, A, B flat, B, C, D. So is that a scale? It doesn't really work too great as a scale. It's more than just an octave, right? From A2 past A3 all the way to D4. So it's an octave plus almost another half octave. There's two different types of B in it, a B flat and a B natural. And then there's a gap between the A and C that has no B at all. So something that we're going to learn, or maybe I just have to tell you, I mean, I haven't derived this principle. But basically, you're not going to ever have a space that doesn't have a letter in it, unless you have a pentatonic scale. And you're not going to have two different versions of the same note name. There's always going to be one type of A, one type of B, one type of C. Might be a C sharp, might be a C flat, might be a C natural. But scales are always going to have just one type of each, or at least 7 note scales. So this is a little review. On the last page I said that what we ended up with there was not a scale, but a pitch collection. We just had a collection of pitches. We sort of gave us a sense of what the note vocabulary that was being used. And this is some just review from a previous presentation. We talked about pitch collections versus scales. So a pitch collection is a set of pitches that are available to a composer or performer on a given instrument in a given musical style. So I have a guitar in my hand right now, so we could just say the possible pitch collection available is all these possible notes all the way up to, that's the pitch collection in a sense. Or it could be the specific notes I use in a piece. So, a Zeppelin song. I don't know why I chose this. If we just said if it's just this over and over again, then we could just say, there's 3 pitches in the pitch collection. Okay, so that's what a pitch collection is. For an instrument like a piano, a harp, marimba, the pitch collection is equivalent to just a complete set of keys or strings or wooden bars in the instrument. For this guitar, it would be all the notes that are on the frets. And like I said, that might be limited if it's a specific piece you're talking about. But the point is that if you are thinking about a vocal instrument, the voice, or a stringed instrument that doesn't have any frets, like a guitar, so a violin, per se, it's much more difficult to figure out what the pitch collection is. And then we can have a definition of a scale, which in the most general sense is just a pitch collection that's arranged from low to high, which is what we did on the last page. But that doesn't end up really working too well because there's that issue of like skipping notes or having too many of the same type of note, too many types of Bs. So this is at least something worth paying attention to. Like, what is a scale? What does it mean in our minds? Why do we practice scales on our instruments? What does a composer use a scale? Does a composer have to use scales? Or are they intuitive to us in the same way that grammar is pretty intuitive if we learn a language young enough? Or do we have to learn these things by, practicing them? What do they mean? And then another question to ask is like, which comes first in any given culture? Are instruments made that are tuned to pre-existing scales, or are scales just the ordered collection of notes found on instruments? So let's assume there's a culture, like the European culture that we were just, European chant melodies, and those melodies already exist. Then if you're going to invent an instrument like the organ, which was, I think, invented around that time, then they might try to tune the organ to match the pitches that people were singing. But there are other cultures, so I'm thinking of gamelan music. In gamelan music, the makers of these, they're all metallophone type instruments. So you can think of like little complex xylophones. But they try to get sounds that are not common, that are not sung all that often. So it's possible that it could be different. Okay. From pitch collection to scale, squeezing all the notes into a single octave. So we had a whole bunch of notes, these guys, on the left, and if we tried to squeeze them into a single octave, this would be a good first step. I chose D arbitrarily, but you'll see in a minute that we didn't have to choose D. And there we get almost a scale. We get D, E, F, G, A, B flat, B natural, C, D. It's not quite a scale in the standard way yet because it's got two types of B, but it's like a D type scale with two types of B. A fancy D scale. So, but we're going to invoke this rule that you can only use one letter name. One version of each letter name. So we have to get rid of one of those Bs. And this is just going to give us two different pitch collections. One that has B natural. And one that has B flat. Did I do that right? Here's the one with B natural. And B flat. Okay, so we'd call those two different pitch collections. We'd call them two different scales too, but we're kind of not yet thinking about these as scales, just as sets of pitches. So a big question when we took this big long string of pitches and just chose D as the first pitch and the last pitch and made a scale about it, how do we choose which note to put on the bottom? Why didn't I do it from A up to A and just throw one of the Bs in there? So I could have done that. So how do we know which one to put on the bottom or the top? We don't know the answer. There's 7 possible rotations for each 7-note pitch collection. So if I did this, I could take the same notes and start on E instead and go from E, F, G, A, B, C, D, E. I could start on F, F, G, A, B, C, D, E, F, etc. And I could sometimes have B flat, sometimes have B. So there's lots of combinations. So let's explore this a little bit more. Rotating a pitch collection, deriving all possible modes. So modes in the old days, up to about 1500, meant something much richer than this, but it's also much more complex. So we're talking about modes, what they mean since about 1600. But anyway, you can just think of these as scales. If you really want to get into the complex history of what modes are in Western music history and ancient Greek music, definitely do it. It's fascinating, and I can show you where to look for that. But yeah, for now, we'll talk about the modes as being types of scales. Okay, so this was our original pitch collection. And I put the little dots at the beginning and the end showing that it could keep going below A, B, C, D, E, F, G, A, B, C, D, E, F, G. I'm just doing the B naturals, right? And then you can keep going after D as well. So it goes on infinitely. How do we choose? So arbitrarily on the Bass page, I chose to start from a low D and go up to high D. But we could do it from E up to E, F up to F, bang, A up to A, B up to B, C up to C. So all of given a pitch collection, like this one, that's got A, B, C, D, E, F, G, where we start in there is called a different rotation. And there's always going to be 7 different possibilities if there's 7 notes in the collection. Cool. So these are all the same pitch collection, but they're different scales because they have different tonic pitches. So what we're going to do now is go back to this page, these little melodies, and see if we can figure out what the resting tone would be for each one. That's an E. That's an E. Hey, da, E, F, E, F, D, G, G, A, B, B, E. So sing each melody and find where the melody seems to pause or spend the most time. Sometimes a melody will emphasize unstable pitches, but a resting tone tonic should feel pretty stable. So when we're trying to figure out what a tonic is, we can listen for what feels like a stable tone. That's why it's sometimes called a resting tone. And I do have to say that with chant melodies is not super easy. It's much easier if you took like any kind of modern tonal melody. It's much easier to hear just from the melody alone where the tonic is. But in these chant melodies, it's less hard. So it's gonna be semi-arbitrary on this page, but that's okay. So, and then once we do that, you're gonna find out what kind of scale you have using one of the 2 pitch collections and the newly found tonic. So in this first one, I'm gonna say that the tonic is E. I'm gonna give us an E again. Da, E, F, D, G, G, A, B, E. So I would say E is the resting tone. If we chose a different one, that would be fine. We might say E, F, D. I think like around there, it kind of feels like maybe D is it. So it could be different, but here we're just going to go with what we choose, and then we're going to diagnose what kind of scale it is based on which we choose as the resting tone. All right, next one. F, E, D, E, F, A, G, A, G. I'm going to choose F. Oh, no, I'm going to choose D, apparently. F, E, D. If I were to do it again, I think I'd choose F. But anyway, so D is what I'm going to choose there. Oh, yeah, F is maybe possibility. Okay, this next one, D. So we have C, D, 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 E, D. And I'm going to choose D. There's a resting tone. Then for the next one, D, C, E, F, G, F, D, D, C, F, G, A, G. I'm choosing F. I think there's an argument you could make that it could be D. But anyway, we're choosing F. This next one, D, D, F, D, D, C, F, G, F, A, A. Okay, so choosing D there. Here we're going to choose D again. Oh, there's so many Ds. F, D, F, E, C, F, G, A, G, A, G, A, B flat, A. So what's going to be interesting here is to look at what this one is. This is going to be D, E, F, G, A, B flat, C, E, C, D. And whereas this one is going to be D, E, F, G, A. Well, there's no B natural in there, but we're going to assume there's a B natural. This one, there's no B. But we'll see what's going to happen if we choose a resting tone with D on D with a B flat versus resting tone on D with a B natural. Okay, let's keep going. F, A, C, 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 D, D, C. And then this one's going to be, I'm going to choose it on A. A, F, A, C, 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 B, A. And then this next one, A, D, C, F, D, 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 C, D, F, E, D, 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 C. So I think that's a D, yes. Let's do this one. D, A, C, D, 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 E, D, C, D, F, F, E, D, etc. So we're going to choose D again. And then D, A, B flat, A, G, E, F, G, F, E, D. I'm going to skip the rest. but we're going to say that's a D again with the B flat there. And then G, C, D, D, A, B flat, A, G, F, A, F, G, A, B flat, A, G, G. So kind of arbitrarily, I'm going to choose G. I don't know which one it is, but G with the B flat. Okay, so we've done this. We've found tonics, and we can guess what our collection is based on whether it's got a B or a B flat. Okay, so let's do this on the next page, and I'll show you what I'm talking about. So in this one, we've got E, F, G, A, B, C, D, E. Some of those notes don't even get stated. E, F, G, A, B, C. Okay, there's no C in this, but we're just guessing that it's a C natural. If it were C sharp, we'd be pretty surprised. So an E, F, G, A, B, C, D, E, that's our collection from, and we're saying E is the tonic. That's why we're doing it like this. So this is going to be E Phrygian. And in a page or two, you'll see what Phrygian is relative to other things. You can think of it as third mode of C, the white notes from E up to E on the piano, or you can think of it as a minor scale with a flat second, but you'll see that eventually. Okay, this next one, D, E, F, G, A, B, C, D. There's no B in this whole thing, but we're assuming it's a B natural. We'd get a different answer if we assumed it was a B flat. In this case, it's going to be D Dorian. And again, you'll get to practice the modes in a later page. We're skipping this one because it's just a repeat. This next one, F. So it's these same notes, F, G, A, B, C, D, E, F, with F as the resting tone. So it's an F scale of some sort. What kind of F scale is it? F, G, A, B natural, C, D, E, F. So it's an F major with a raised fourth. So we're going to call it F Lydian. D, E, F, G, A, B flat, C, D. So this is going to be D Aeolian. C, D, E, F, G, A, B, C, C major, C Ionian, A, B, C, D, E, F, G, A, so it's A Aeolian. And then this last one, we're skipping these two because they're just repeats. G, A, B flat, C, D, E, F, G. So it's a G scale, and then it's got the one flat in it. So G, A, B flat, C, D, E natural, F, G. If this were an E flat, it would just be a plain old G minor, which is G Aeolian, but this is G Dorian. And hopefully the following screens will clarify this. But in answer to the question, we could look at a corpus of melodies, which is this, figure out what the pitch collections are and the resting tones, and then derive from them scales, and then we just need to give those scales names. We're doing that, we're giving them names based in part on the pitch collection. In this case, it's just whether it has a B flat or a B natural. And then also the resting tone. So the resting tone says that this is, even though these are exactly the same notes as these notes, we're saying that this has D as a resting tone. So this is D Dorian, whereas this is E Phrygian. Okay, that's the idea. So I showed you this on a previous screen, D, E, F, G, A, B, C, D. These are always the same notes. It's a single pitch collection. It's just the white notes of the piano. But from D up to D is that thing, which is D Dorian. From E up to E is E Phrygian. From F up to F is F Lydian. G up to G is G mixed Lydian. A up to A is A Aeolian. B up to B is B Locrian. And C up to C is C Ionian, which is major. This guy's, that C is major. This A is minor. Natural minor. And then if we had the same exact thing, but instead of all the B naturals there, we've got B flats. This is a different pitch collection, so this is still a D scale from D3 up to D4, but now this is D Aeolian, this is E Locrian, etc. So let's take a look at that. That D scale is D Dorian, because it has a B natural, whereas this is D Aeolian, and Aeolian just means natural minor. This one's E Phrygian, whereas this one is E Locrian, and that difference is the B versus B flat. So they're both E scales, they just have different names. This one's F Lydian, this is F Ionian, G mixed Lydian, G Dorian, A Aeolian, A Phrygian, B Locrian, B Lydian, B flat Lydian, and C Ionian, and C mixed Lydian. Okay. Like I said, the aim of this next part of the presentation is to make this a bit clearer.